Yes. Okay, good morning class. So, but shorter lesson today because you guys have written a test, a class test. I'm sure you guys have nailed that one. Otherwise, we'll do the memo to that test tomorrow, okay? Please answer the questions again at the back of your maths books. This time you have the opportunity to look through your previous sections of work, okay? You guys had some homework. The homework was on exercise 1 on page 35. Is that correct? Any problems with number 1? Number 2? Number 3? Yes. Number 4? Number 5 I did on the board yesterday, the last lesson. Number 6? Okay, well, it sounds of it you guys didn't do your homework, so I'll do number 6 as well. If nobody's asking for number 6, then clearly you guys haven't done your homework. Am I right? No. Am I not right? Okay, then I'll leave number 6, no problem. Then number 6 is a common asked question in the exam. That's fine. The learners get it wrong in the exam. But no, it's fine. I'm not going to do it because you guys have done it and you don't have an issue with it. So let's look at number 3. In number 3 we are told that state how the range of each graph should be restricted so that it become a function. So currently, is this a function? Is 3.1 a function? No. Of course not. Okay, so why is that not a function? No. Why is it? Does not pass the vertical line test. If I take the vertical line into account here, okay, you see here, this graph is cutting this vertical line twice. Can you see that? So it's not a function. So they want to know how can you restrict the range. So what is range? All possible y values. How can you restrict the range of the graph in 3.1 so that it becomes a function? So if you consider this part of the graph here, if I take that part of the graph only, is it now a function? Yes. Why? It passes the vertical line test. Or if I had taken the bottom part of this graph, coming from 2 down, would that now be a function? Yes. So how can we restrict the range of that function so that it become a function? In the first case, we say y must be greater than or equal to 2. In the other case, y has to be less than and equal to 2. So it's either or. Okay. Look at the next one. 3.2. Again. If I take that part of the graph, is that the function? Yes. So in other words, y must be greater or equal to -1. Or this bottom part of the graph, which is y must be less than or equal to -2. If we look at number 3.3, why is this not a function? Does not pass the vertical line test, cutting that vertical line more than once. What type of relation is that? Many to many. Why? Because that's a many to 1. And if I go this way, down. That's a many to one, and that's a one to many. Can you see that? So in other words, it becomes a many to many relation. Okay. It's not a function because it does not pass the vertical line test. However, if I restrict, if this is your line y is equal to 2 here, going through like that, if I take this top part of this graph, remember this is y is equal to 2 there. So this of course is 4, because your radius of course is 2. So is that a function? Is this a function? Yes, why? Passes the vertical line test. You look on the other end. Comes below like that. This is your 0 here. So what would this be a function? Yes, it passes the vertical line test. So how must the range be restricted so that it can be a function? Y must be more than or equal to 2. Or y must be less than or equal to 2. Okay, and that is how we restrict the function of these, or how we restrict these relations so that the relation becomes a function, or the graph becomes a function. Alright, so that now brings us to inverse functions. Okay, that's your heading for today, inverse functions. So we are told the inverse of a function. You obtain the inverse of a function by swapping x and y, the x and y values. When else did we swap the x and y values around? Under what other condition did we swap the x and y around? A reflection is in the y is equal to x line. Okay? Remember we did transformation geometry last year, and we did rotations and reflection, mainly reflections in the x-axis and y-axis. If something is reflected in the x-axis, what happens? Y becomes negative. Something reflected in the y-axis, x becomes negative. Something is reflected in the y is equal to x line, x and y becomes y. Okay. So the whole inverse function idea is based around the fact that the graph is reflected in the line y is equal to x. Hence the reason why you obtain the inverse of a function by swapping x and y values. You understand? The domain becomes the range and the range becomes the domain. Because if you swap x and y around, the domain which is x becomes the range now, and the range which is normally y becomes the x which is the domain. Again, the domain becomes the range and the range becomes the domain. A one-to-one function becomes a one-to-one function. Why? Because if you swap on your x 1-to-1, your x1, it becomes y1. If y is 1, it becomes x, which is also 1. So you're 1-to-1. If you swap x and y around, it becomes y and x. Not so 1-to-1 remains 1-to-1. Make sense? But a many-to-one function becomes a one-to-many relation. It's not a function anymore. And a good example of that is exactly what we have done now. If we take that parabola into account for argument's sake. Okay? And we reflect that graph in this line y is equal to x. Then that is what the graph is going to look like. Can you see that, people? You'll see now the drawing will be a bit neater. But if we reflect it in the line y is equal to x, this arm here is that arm there. Can you see that, people? Going through the 0, of course. And this part of the arm of the graph is going to be equal to that. Can you see that, people? So this is a many to one function. However, this is a one to many relation. Okay, we don't call it a function. Why? Why is that not a function? Because it does not pass the vertical line test. Okay. So we are told, but a many to one function becomes a one to many inverse relation, which is not a function. Only one to one function can therefore be, and therefore have the inverse, which are functions. Many to one functions requires the domain to be restricted, so that the inverse be a function. Okay, we'll look at an example of that. By swapping x and y values, we get x and y becomes y and x. We've done that last year as well. We'll do it again this year. Okay. Here's my page number 36. Let's carry on with the lines. We are then told this means that the graph is reflected about the line y is equal to x. I've indicated that. The graph and its inverse are therefore always symmetrical about the line y is equal to x. People, what does symmetrical mean? Okay, it's a mirror image. I'll tell you, it's a mirror image. Okay, it's a mirror image. Where did we also hear the word symmetrical? When we do the parabola. Not so. Did we calculate the axis of symmetry? Not so. So the axis of symmetry is basically the mirror image. If you look at a parabola graph, the axis of symmetry is the line that's going through like that. Not so. What is that? Why do we draw that line? That line is our guide to show that what's on the left hand side of that line is equal to what is on the right hand side of that line. It's symmetrical. So if I take the distance from there to there, it's the same distance from there to there. Okay, you guys understand? Anyway on that curve. Okay. So we are told that it will be symmetrical about the line y is equal to x. If you're coming back to this graph here, I could have folded this graph close in this line. Which means to say, if I take this left hand side of the graph and I fold it close in this line here, then that part of the graph will fall exactly onto that part. Likewise, the symmetrical graphs, if you must fold it close in that line y is equal to x, that graphs will fall exactly onto each other. Does it make sense? Okay, I'm talking again to myself. Oh yeah, this is that group, no? Right. You use f to the minus 1 to represent the inverse function. F to the minus 1. Alright? If to the minus 1, if we got x to the minus 1, we know x to the minus 1 is what? 1 over x. However, f to the minus 1 of x is never equal to 1 over f of x. Make that note there. Very important. Okay? F to the minus 1 of x is never equal to 1 over f of x. Okay? And that denotes inverse function. If the inverse is not a function, if the inverse is a function, we use the notation f to the minus 1 of x equals. Okay? Be careful not to mistake the negative 1 in f to the minus 1 for an exponent. That is exactly what I just said now. Yeah? F to the minus 1 does not mean the reciprocal of 1 over x. Okay? If that was maybe f of x, that raised to the minus 1, that is 1 over f of x. Not so? Likewise, when we spoke about cos and its inverse, cos of theta, cos to the minus 1 of theta, that is also not equal to 1 over cos of theta. Not so? Because this is a function. Cos is a function. Not so? So, that is also not the case. So, importantly, f to the minus 1 of x is never equal to 1 over f of x. Okay? Alright, let's carry on. How to find the inverse of a function? So you write this down, it's very important. How to find the inverse of a function. Number 1, replace f of x with y. Number 2, swap x and y. Number 3, solve for y in terms of x. Number 4, replace y with the f to the minus 1 of x if the inverse is a function. Okay, we'll speak about that later. How to plot the inverse function. Sketch the graph of f using key features, intercepts, turning points and asymptotes. Draw in the line y is equal to x, which is the line of reflection of symmetry. And the number 3, reflect the key point on the graph of f above the line y is equal to x. So sketch the graph of f to the minus 1. You guys ready? Huh? Okay. So now you're looking at work example 1 on page 36. Work example 1 on page 36. We are given straight line y is equal to ax plus 2. That's a general format now basically of the straight line. Okay, or y is equal to mx plus c is the same. We are told that if f of x is equal to 2x plus 2, find the inverse, or f to the minus 1. So, how do we find the inverse? What do we do first? We replace f of x with 1. So now, write this down there. Write example 1, page 36. You write f of x equals y is equal to 2x plus 2. And then you do the first step. Replace f of x with 1. Yeah, this time they gave you f of x equals y, which is equal. Most of the time they just say f of x is equal to 2x plus 2. Okay. What is the second step? Swap x and y. So swap x and y quickly around. Swap x and y around. So you swap x and y around, we write here on the side inverse. So that we know at this point it became the inverse function. Okay? So you got x is equal to 2y plus 2. What's the next thing we need to do? Solve for y in terms of x, which means to say you must make y the subject of the formula. So do that quickly. Make y the subject of the formula. You all got that? Right? What's the next thing? The fourth one is replace y with f to the minus 1 if the inverse is a function. Is this inverse a function? Yes. It's a 1 to 1 becomes 1 to 1. So it's f to the minus 1 of x equals y, which is equal to a half x minus 1. Do we all understand? If I should draw those two graphs, I must draw those two graphs, this is what you should see. Okay, if I draw both graphs, this is what you would have seen. This is the f of x graph here. Remember, this will have a y-intercept of 2 and an x-intercept of minus 1. Not so. If I draw this graph here, you'll have a y-intercept at minus half and an x-intercept of 2. Can you see that, people? What do you notice? It's reflected in this line y is equal to x. So whenever we draw the inverse function and function, we always draw in the line y is equal to x. Make sense? Okay. And this clearly you could have seen. If I take this point into account, what is that coordinate? Minus 1 and 0. If I swap minus 1 and 0 around, it becomes 0 and minus 1. Hence that point there. You take this point into account, which is 0 and 2, swap that around, it becomes 2 and 0, which is that point there. Does that make sense, people? Yes. The half. Okay, just take a step back here. So you took the 2 over, not so. So you got 2y is equal to x minus 2. What do you have in your first line here? So, but you want y as the subject of the formula. We never have 2y in front, so we divide by 2. So you got y is equal to x minus 2 over 2. We have to split each one of its own. So y is equal to 1 over 2x, so x over 2 minus 1. Make sense? That is because it's a function. What type of function is this inverse? It's a 1 to 1. Okay. Any confusion there? No? Let's look at worked example 2 on page 37. So given parabola y is equal to a to the ax squared, y is equal to ax squared. So the question is, if f of x is equal to 2x squared, find the inverse, find f to the minus 1, which is the inverse. Okay, can you guys do that with me? You know what to do? Oh my word. Pray for me, people. Okay, you guys finish? Nice. Right. So what's the first step we need to do? Replace f of x with a? So y is equal to 2x squared. Then what do we do? Swap x and y. Right, inverse on the side. X is equal to 2y squared. Now what do I do? Like y the subject of the formula. Okay? So that's going to give us, so I divide by 2 first. Okay? So I can't go straight square root because of that 2. So that cancels. So y squared is equal to x over 2 or 1 over 2x. Both is correct. Okay? What do I do now? Square root. If I introduce square root, I must not forget. So y is equal to plus minus the square root of x over 2. Or, in that case, it will be plus minus the square root of half. Is that inverse a function? Huh? Remember, what type of function is this? What type of function is f of x to start off with? The parabola. If I draw this graph, I just take key points here. X, y, I always go 1, 0 and 1. So, what would f of x be? Let's just make this a bit bigger. X and y. What would y be if x is minus 1? What would the value of y be? If I put minus 1 into that formula, undefined. 2. How is it undefined?
I put it in an answer.
In this one here?
Yes, sir.
This one here, f of x. You're going to get 2. Put 0 in? 0. Put 1 in? 2. So if x is minus 1, y is 2. That's all. X is 0, y is 0, x is 1, y is 2. So there is that graph. That's all. And that is your f graph. So what did we say earlier on? What do we do when you work on your inverse function? We swap x and y around, not so. So if you swap that around, this point of minus 1 and 2 becomes 2 and minus 1. Okay. This graph is not drawn to scale, no? So it won't look so symmetrical. But anyway, 0 and 0 becomes 0 and 0. 1 and 2 becomes 2 and 1. Can you see that, people? There is that graph. And this is your inverse graph. It's actually not a function, but it's the inverse graph. Not so. Why is it not a function? Does not pass the vertical line, please. A common asked question. Okay, before we do anything else. What is the domain of f and the range of f? Write that in quickly. The domain of f and the range of f. What is domain? All possible x values. Yeah. Your range was all possible y values. So just you answer that question for me quickly. This is right inverse before you get confused, no? The inverse. Okay, so what's the domain? What will the domain of this red graph here? X is an element or real number. What's the range? Y is greater than or equal to 0. Why? Because does this f of x graph exist at negative infinity? No. Where does the graph start existing at? 0 onwards, from the origin onwards. Not so. So y must be more than 0. Does the graph exist at 0? Yes, because it's going through the axis at 0. Therefore it has to be more than and equal to 0. Yes, Michael?
So, can you write it down in the other ways also?
Yes, you can. Y is an element of block bracket 0 infinity curve. If they ask you what is the domain and the range of the inverse function, domain of the inverse function, the range of the inverse function. If you look at this graph, the inverse graph, does this graph exist at negative infinity? Sorry, your domain is all possible x values. Does this graph exist at negative infinity on your x? No. Where does it start existing at? 0 onwards. So it's going to be x and 0. But it has to be more than or equal to 0. Not so. Let's look at this, the range of this graph. The range is all possible y values. Now you see these arms goes open like that. Not so. So does this graph exist at negative infinity? Yes. Positive infinity? Yes. So y is an element of or real number. What do you notice here? What do you notice? It's basically swapped around. Can you see that x is an element of real numbers? Y is an element of all real numbers. Y is greater than or equal to 0 and x became greater than or equal to 0. One more question which is commonly asked. How can we restrict the domain? Let's close it quickly. How can we restrict the domain of the function so that the inverse can become a function? So if you look here, how can we restrict the domain? So the domain is possible x value. How can you restrict the domain of the function so that its inverse can become a function? So if you take this part into account here, can you see this? If I take that part into account, remember the 0 and 0? Negative 1 and 2 becomes 2 and negative 1, which is that point there. Can you see? So if I take this part only of the graph, would its inverse be a function? Yes or no? Yes. So how can that be restricted? It can be restricted by saying x has to be less than 0. Can you see that, people? And equal to. So we say x has to be less than or equal to 0, or if I take this part into account here, so that is 1 and 2 became 2 and 1, and 0 remains 0 and 0. That part of the graph became this part here. Is that a function? Huh? Yes. So how can that be restricted so that the inverse can be a function? X must be greater than or equal to 0. Or x must be greater than or equal to 0. Again, this question would read, for which values of x? Determine the values of x for which you will restrict the domain of the function so that the inverse can be a function. And the answer to that is x is less than or equal to 0, or x is more than or equal to 0. If you look at how this graph is drawn, there we go. That is drawn by the computer there. No? People, for homework, you do me exercise 2. We do numbers 1.1, 1.2, 1.3. We do number 2. And number 5. Okay. People, enjoy the rest of your day. Good morning, class. Okay, we number 1, number 2, ne? And 5. Okay. Okay, come inside. Just put the white in front of the door, please. Sanitize everybody. Thank you.